Okay, good afternoon, and once again, I'm Peter Emmanuel, and in this video, I'll be taking you on differentiation. So I'll start from the basics of differentiation, basically what is known as power rule. This is just the basics I want to start from. Now, in differentiation, all they mean is differentiating a value or a variable with respect to another one. I just have y equal to x squared. I want to find how much would the change in x affect that in y. A change in x, how will it affect that in y? I'm trying to measure it. So I'm going to use basically the power rule. Now I'm going to try to make this as simple for you as possible. Now power rule in let's say layman language, simply power come down, power go up minus 1. So I have x squared, to differentiate this. So power come down, power go up minus 1. This is the power of x, 2, that's squared. Power come down, 2, this multiplied by x, power go up, that's 2 minus 1. So power come down, power go up minus 1. So 2 times x gives me 2x, 2 minus 1 gives me 1, which same thing as 2x. So the same thing as where I'm told to differentiate x raised power n, that's any value, taking n to be any integer, is simply going to be power come down, n multiplied by x, power go up minus 1, n minus 1. It gives me n x n minus 1. This is for my dy dx. This simply means differentiating y with respect to x. So whenever I see wrt, it simply means with respect to. So like differentiating y with respect to x. Okay, let's make this a bit more complex. Assuming I am given y equals to 3x cubed. Again, we use our normal power rule. So dy dx, or I can say change y change in x, is equal to power come down, power go up minus 1. So the power here is 3. If 3 is coming down, it's going to give me 3.3x. This is the power coming down, 3.3x, power go up minus 1, 3 minus 1. This for the x. So 3 multiplied by 3x gives me 9x. 3 minus 1 gives me square 2. That's 9x squared. Now another long form of differentiation that will still give you the same answer with the power rule is what is known as first principle. So in the next video, I will be talking about differentiation using first principle. But for now, I want us to focus basically on the power rule. So this is the basic thing of what the power rule is telling us. It's telling that we have y is equal to x squared, x raised power n, as any integer. We're differentiating both sides. We're differentiating y with respect to x. It is simply going to give me power come down, power go up minus 1, and minus 1. It gives me n x and minus 1. This is the basics for the power rule. Then later I'll also talk about the opposite of differentiation entirely. That is what is called integration. This is the complete opposite of differentiation. So let me just take one more example. Okay, assuming we are given our y to be equal to 9x raised power 4 raised power 4x. Yes, 9x raised power 4x. Now if I'm differentiating this, my y is simply going to be my dy rather dx is simply going to be power come down. The power here is 4x. Power come down, power go up minus 1. So this 9x 4x minus 1. So this gives me 4 times 9, 36. X times x squared, open bracket, 4x minus 1, which is simply 36x. If I'm factorizing this out, gives me 8x minus 2. Now, if I have this, all I've done here is giving you guys the first derivative, the y dx is the first derivative, then the square y, the x square, the second derivative, the cube y over the x cube, third derivative, the raised power 4, the fourth y, all over the x raised power 4 is the fourth derivative, and this keeps on continuing, just keeps on going. So this can also be written as y prime. This can also be written as y prime prime. This can also be written as y prime prime prime. And this I will just say right as yiv in terms of Roman numerals. Then assuming I give you y is equal to 9x cubed plus 3 plus 3x. Okay, 9x cubed plus 3x. And I ask you to find the third derivative for me. I'm simply asking you to find y prime prime, which is y cubed over the cube y over the x cube. So this gives me the y, the x to be equal to, if I differentiate this first one, it's going to give me 3 come down, that power come down, 3 times 9, 27, x power go up minus 1, 3 minus 1, plus here will be power here is 1. When the power comes down, give me 1.3 x 1 power minus 1, that's 1 minus 1. This is my dy dx, so this is going to give me 27 x 3 minus 1, 2, plus 1 times 3 is 3, x raised to power 0 is equal to 1, so this is 3 times 1, that is just 3. So that's the first derivative. Second derivative by the x squared, this is d, that's a d, gives me second derivative. I will differentiate this first derivative I got to give me the second derivative. So if I'm differentiating 27x squared, this gives me power come down 2 multiplied by 27 x power go up minus 1, 2 minus 1, then plus 3. Now if you are differentiating any constant, it's going to be 0, and I'm going to show you why. Okay, so the power of x here is 0. Remember, that's 1, 0. So if I have 3x power 0, it's still going to give me power come down, that's 0 multiplied by 3, power go up minus 1, minus 1. You get it? So this gives me 2 times 27 gives me 54. X minus 1, 2 minus 1 rather, gives me 1. That's 54x. Now, 0 times 3 is simply 0. 0, that's 0 times x raised to power minus 1. Since as 0 times 1 over x, anything times 0 is still 0. So this is my second derivative. And now for my third derivative, that is the cube y dx cube, that's y prime prime. So let me minimize the space, y prime prime is going to give me, if I differentiate this, what do I get? The power here is 1. So 1 coming down gives me 1 multiplied by 54. 1 multiplied by 54 times x What power of x? 1. 1 minus 1. That's power come down, power go up minus 1. So this gives me 1 times 54. 54 times x raised to the power of 0. So x raised to the power of 0 is 1. This gives me 54. Now, if you noticed, in the presence of addition sign, I differentiate them separately. I'll do so in also the presence of a subtraction. If it was subtraction, I'll still differentiate them separately. For a situation whereby I have multiplication, something like this, or something like this, I'm going to apply what is called product rule. That is meant for multiplication. Okay, I'll deal with this in the next video. And we also have 5x cubed over 3. This is what is also called quotient rule. It's meant for division. So in case you are given multiplication, you don't go and differentiate them separately. No. You have to apply what is called the product rule. And I'll take you later on that in the next video. Thank you.